Evaluating the quality of a model is a long-standing challenge in robotics. This makes it incredibly difficult to define a clear path towards improving autonomy. Currently, evaluating a general-purpose AI model requires running physical trials across the full spectrum of scenarios it might encounter. This corresponds to a lifetime of experience in the real world. That's why we built the 1x World model, which serves as a bridge between atoms and bits. The world model is a digital twin of the real world that predicts the future consequences of a robot's actions. This deep generative neural network allows us to compress that lifetime into an instant.
The 1x World model tackles the complexity of the real world by learning directly from thousands of hours of robot interaction captured from raw sensory data. This enables us to model complex physical interactions, such as the grasping of delicate objects, collisions between rigid bodies, and the deformation of objects when manipulated, giving our model a firm understanding of the physics of the world around us. As we scale up our data, especially from interesting failure modes where Neo's task execution doesn't go exactly as planned, we find that the quality and accuracy of our world model reliably improves. This pattern of improvement mirrors trends observed in other large generative models, where the capability of the model scales with collecting the right type of data.
Practically speaking, we leverage the world model to quickly assess and compare across many different policies. With a general model like Redwood that is trained to handle many different tasks across different environments, the world model lets us evaluate its capabilities with measurable results, shortening our iteration speed from weeks to minutes.
Here at 1x, we've experimented with different modalities and sources of data, including web-scale video data, first-person perspective human data, and teleoperation. But we found that the most important type of data for scaling up the capability of our world model is Neo autonomously interacting with real environments, attempting real tasks, and succeeding and failing in interesting and diverse ways. We are only able to collect this data at scale because Neo is a safe and compliant robot capable of continually running in unstructured environments.
Beyond just evaluation, the world model can fundamentally change how Neo approaches decision-making. By continuously visualizing future states, Neo can effectively use the world model as its cognitive core, dynamically planning and adjusting its actions based on predicted outcomes. This predictive capability allows Neo to execute tasks more successfully, adapt more quickly, and handle unexpected events gracefully, bringing us closer to truly intelligent general-purpose robotics.